So in this video, we're going to see a graph theory 2 marks question from the year GATE 2017, and it is based on the topic of minimum spanning tree. So let's see what the question is. Let GVE be any connected undirected edge weighted graph. So G is any graph and the weights of the edges in E are positive and distinct. Now consider the following statements. Now before we go ahead, let's make a note of whatever has been given so far. So we see that we have a edge weighted graph. So let me take a small example of an edge weighted graph. Let's have an edge weighted graph of 4 vertices. Okay, let me connect them with the edges. Okay, random edges, and the question says that the edges in the E are positive and distinct. So let me give them distinct weights: 1, 2, 3, 4 and 5. Okay, so these are the edge weights. Now let's see what the question says further. Consider the following statements. Now there are 2 statements. Statement number 1, minimum spanning tree of G is always unique. Okay, and statement number 2, shortest path between any 2 vertices of G is always unique. Now which of the above statements are necessarily true? So we have to find out which of the above statements are true for any G, which would be an undirected edge weighted graph. Now whenever such theoretical general questions are given, we start with a small example and we try to see if any of the statements are true or false for the given example. So as we have already seen, there is one, we have taken one small example of a graph with the random edges and random weights. Now step 1, we are going to find the minimum spanning tree of the G. So very simple, the minimum spanning tree of this graph, is nothing but it will have this edge 1. Okay, let me make a note of it. Then it will have this weight edge 2. So 2 will be there, and it will have this 3. So 3 will be there. That's it. This is my MST for the given graph. Now if you try to notice and try to think about it, since the edge weights are distinct, here it is given in the question. Since the edge weights are distinct, the minimum spanning tree is always going to be unique. You cannot have 2 different minimum spanning trees for such graphs because the edge weights are distinct. If there were some edge weights which were similar, which had same values, then we have choice whether to take this weight or that weight. But since here the weights are going to be distinct, the minimum spanning tree is always going to be unique. So statement number 1 is true. I'm going to mark it true. Now let's go to statement number 2. Now statement number 2 says that the shortest path between any 2 vertices is also unique. Now, let's think about it. Now if you think about okay, so let's consider this vertex. Let me name it. Let's consider this vertex A, B, C and D. Okay, now the shortest, now let's see the shortest path from A to C. Okay, now there are different ways to reach from A to C. We can go by ABC, in which case the weight is, in which case the distance travel will be 5. Okay, 2 plus 3. Or we can go from ADC, in which case also the distance is 5. 1 plus 4 is 5. So as you have seen here, that the shortest path between any 2 vertices of G is always unique. This is false. It is not unique. Here we have seen we have 2 different paths, ABC and ADC, to travel from A to C. So third statement number 2 is clearly false. So now which of the above statements are necessarily true? So option A, 1 only, is our right answer.